please? No.
No, sir.
No, right. Okay. Now this is like a very introductory module that I'm going to do. Initially, I'm going to present about what's a computer and what are the features and the domains that are majority of the cases that we are applying, and what about the data and information, and what are the characteristics, input and output and processes kind of things, and a few little bit about the computer generations. So we'll go through this agenda today. Initially, what's a computer? As per the Britannica definition, it's an encyclopedia. According to that, a device for processing, storing, and displaying information. So, what's the purpose is processing, storing, and displaying information. So, it's a device. What kind of a device? It's an electronic device. It's an electronic device operating under control of instructions stored in the memory unit. So what's happening there? So the instructions are stored in the memory. So what we are usually happen in our brain, there are set of instructions are stored in our brain, right? Like, as same as the computers store some set of instructions, logics. According to that, computer takes suitable, relevant actions. On the other hand, that can accept the data. So always computers are majority of the cases accept some sort of data from the external environment. External environment means the environment that human are living, or it might be another computer network, or it might be another set of computers joined together. Such cases also there. So it accepts some sort of data. That means it grab the data, it absorb the data, it computers can get the data from environment, and it manipulate. What's the meaning of this manipulation is, after the extraction or the getting data to the computer, it process it. I'll give another example. As human, what we are doing, we are send some information. We'll get some noises outside. My ears are sensing that input. After input this noise, my brain process it, or my brain manipulate it according to the specific rules. So there are set of rules in my brain. This is a car, this is a van, kind of examples. Same way, computers do the same thing. It process the data according to the requirement. If we need to extract, or if we need to process data related to an earthquake, so it process accordingly. If we need to get some sort of decision, if we need to get some sort of decision like auto driving car, so there are set of rules, there are set of processes are running in and out. And the other way around, it produces information. What it does is, it produces some information to the outside. What the computer does, usually it extracts the data from outside, it processes according to the rules that define it by itself, then it provides some sort of output. This output is defined by the human, because what a computer, the main requirement of a computer is to do some work instead of a human, or some sort of automated work, or some sort of hard work, or it might be time consuming work. There are, in such cases, computer involves to make the process easier, sophisticated, and more robust solution for us, and it grants, or it provides the output for us. So that's the main scenarios in the computer. Apart from that, it stores the results for the future use. What computer does is always it stores some sort of data. Majority of the cases, it stores some sort of data for future use. There are different data storing mechanisms. Today we are discussing about that also. And this data storage can be used sometimes in real time. That means the data process, once it arrived, it store the data. Sometimes after historical data analysis, we can predict something. By historical data. We have the 35 years of rain data collected. How is the rain fallen? We can predict because we have stored the data. And that is very interest and very important for business decisions especially. And now you have good understanding about what is a computer. In general case, a computer is an electronic device which can accept some sort of data from outside. Then it process, then it provides an output. In the same way, it stores the data. And hopefully you have already worked with computers, lot of applications, games, movies, or what kind of things, any large number of activities you have done. That's the common scenario. You have majority of the cases you have used. I'm pretty sure. uh, I just want to know if someone is you don't want to chat with everyone. Can someone please chat with me if you have never used a computer, or for this session if you are using a mobile application, could you please chat with me and say I'm using mobile phone or I haven't used a computer at all. Can you please have a chat with me, or just one sentence is more than enough to, I just want to get the information about my audience. Clear? So can I'll give 1 minute for you. You can just buzz me or have a chat with me for 1 minute. If anyone haven't used a computer forever, this is the first time that you are using a computer. In the other case, if someone is using mobile phones, the mobile phones means this subject contains a practical. So for that, I'm conducting Microsoft Word. So that's why I'm asking, you have to move for today. It's okay, but from the next day onwards,
Mobile.
sorry. Okay. Next day onwards, you have to definitely, okay. Definitely what you have to do is definitely you have to move to uh, computer, because Microsoft Word is conducting for you in next session, not today. So kindly be right. I'm getting few people are using mobile phones. So for today it's okay. For the next day onwards, so kindly move to computer or a laptop or whatever a device that can run Microsoft Word. Clear? Unless right, thank you. I'm getting there are people are using mobile phones. It's like usual scenario, but from the next day onwards, please they have to move to desktop, like or a laptop for this session. Morning sessions I'm going to do present about like theories, and evening session I'll go to do practical. So morning it's okay to use a mobile phone, but for evening sessions please move to your laptop or a desktop, because we are doing some practicals. I'm giving chances to you also. Instead of speaking continuously, you can do the practicals with me on the fly, so it makes more sense rather than doing just a lecture. Okay, so morning sessions it's okay, but evening sessions please kindly enough to move to a desktop or a laptop. Clear? So thank you. So hope everyone have used like a computer, right? So no worries for that. Right. right? Some sort of characteristics. It's very speed. Actually, you may realize how much speed the computer is, and we don't want to specially tell about that. Computers are really speed, and it's very accurate. You may see a lot of scenarios, uh, like human may get wrong, but computers get continuously accuracy. But it doesn't mean the computers are 100% accurate. As an example, like cutting edge technologies, face recognition. I'll get an example: face recognition. There might be inaccurate situations. If you are using Google Maps, you have faced for some situations that is not perfect, 100% accurate. But I'm speaking about in the general case, in general situation, it might be high accurate than a human. I'll get the same example. You may ask from location, one location to another location. We'll get example from Colombo to Jaffna. If you ask from a human, that person will interpret according to his experience. So if you are using Google Maps, you may get the shortest minimum time to move to Jaffna. Clear? So that is more accurate than human. But there are situations, I'm agree with you, there are some situations computers are not the highest accuracy. There might be some situations that are not highly accurate, but nearly 95% it's highly accurate. And consistency, what's the meaning of consistency is it provide a data or information for a long time without any modifications, or there's no any differences or changes. If you take a person and if you give some sort of information, you have given some sort of information to a person, that person can memorize up to some time. Sometimes after 10 years, if you ask the same thing, that person will answer in a different way. The data is inconsistent. What you input is not in the there, not in there. Sometimes if you store some sort of information in another person's machine, it might stay for 10 years consistently. It won't change, but uh, screen was gone or something happened, right? Can you hear me, please?
Yes, sir. Now we can hear you.
What about the screen?
The screen is not visible.
Screen is not visible. Just a second, okay? Right, somehow your screen will come within 1 second, right? somehow. Now, consistency that we have speaking about this consistency, that means it stay the data continuously. It won't change time to time. If you have saved some sort of photo in your computer, it won't change time to time. It's consistent. It's like the same photo after 10 years. If you go through the same photo, you can see. If you save some sort of document, it would be stay continuously 10 years or 15 years or until the hard disk is corrupted. In the same way that I'm telling about, though it's highly consistent, there are situations that are not consistent. As an example, if you have used a CD, unfortunately, if that was broken, your entire data will be not there. But it's a storage device. But your computer, the same situation. If your computer is, lot of students face such kind of situations. Hard disk is not more, it's not working furthermore. It was all of sudden everything was lost. Probably you have faced this kind of issues, right? Consistency. Computers are highly consistent, yes, agreed, but there are some situations we have to face, right? And automation. Now the automation is very good characteristic in a computer, because of this automation, people was using computers majority of the cases, especially in the business. If you are using a computer for your business, it might be a continuous work for 10 people, and you can replace by a computer and execute the same process within 5 minutes or 10 minutes. It might be less than 5 minutes. The whole processes can be automated. This is very powerful characteristic in computer. You may see a lot of queues in banks, government places. Lot of queues are there because there is a human intermediate processes are there. But if you are doing something like online, you might get very minimum time, because the computer does the work for us in very rapid or fast way, because the process is automated. The entire process was automated. If you see a queue, that means there is something lagging in automation. If your computer is automated well, then you can even sometimes shut down your computer without your interpretation or your intermediation. That much of automation is there. Not only this simple automation, there are, if you once you learn further, you will realize the entire processes, software development processes are automated. The executions are automated. All of these are related to these characteristics of the computer, and these are automated, right? There are a whole lot of characteristics. I'm just mention about these four. Please realize you can learn up to the extent that you can, if you want, right? Don't stop from only for these four. If there are 25, you can learn about these 25, because these are university lectures, so probably you have to change your attitude too, because this is not like spoon feeding system, right? Now, what are the fields? Usually that education. Now, you may realize even now you are learning by using a computer, and there are a whole lot of online courses are there. Education sector and entertainment. Simply, everyone is entertained with YouTube. Everyone is watching movies, right? All through these computers, and these are businesses behind the scene. These are businesses. Education as a business, there are a lot of companies are doing some sort of business, education business. And entertainment, there are a whole lot of businesses are behind the scene. And social networking, computers are widely used, very widely used. Computers are applied, and majority of the businesses at the end of the day. Last but not least, what I want to emphasize, almost all the industries are injected with the computer. Now, if you visit a place, you have to search, is there a computer or not? I'm pretty sure you can't find any industry without a computer. If there's a industry without computer, means that is very old or very time consuming, inconsistent process, not well process defined industries there. I'm pretty sure, right? So you may realize everywhere in the world, every industry injected with the computer. Nevertheless, your degrees, whatever, you have to learn about computers and how these computers are working. That is very important for you, right? You might go for your job for different business vectors, whatever the vector, you have to deal with the computer, you have to know about computers. This is mandatory for everyone, right? Now classifications. Now these are like very old classifications. Nowadays these classifications are not much involved. This classification is conducted based on the size. Now you might see there are 4 images. These images can define the size. You can see very simply. There's a very large, very small, small, and medium, another size. Now, these are classified. These are classified based on mini computers, microcomputers, mainframes, and supercomputers. Mini computers are the very small or very least processing power, and very small activities can be performed. This was like very old scenario I'm speaking about. And microcomputers, these are microcomputers, kind of enhancement of mini computers, but still they are very lagging. Mainframes are like larger computers. They can process large amount of data, and it has some sort of really high powerful, and the size is very large by comparing to microcomputers, and mainframes are very large differences are there. And supercomputers are very large. These are really large set of computers, and it has very superpower, and it has lot of processing power. Nowadays, actually there's no need to do a special classification like kind of a size. Instead of the power, the processing power is something valuable than the size, because we don't want to care. Probably you don't want to care. I'll give an example. Do you care about the size of where your Google data or Gmail data is stored? Have you ever thought about that? How much is the size? You don't care about that. It's okay. It might be very small or very large. You don't care about that. That's the scenario, right? Whatever the size is, it's okay for us. But think a computer that you are using, very slow computer, you'll really think about that, isn't it? So nowadays this classification is not much relevant for our generation. Now there's another classification. It's based on the technology. The classification done based on the technology, this also kind of old, very old, but I have seen somewhere it's like still very rarely using. The first one is analog computer. You may see an image of this. This also very old. Actually, it was obsoleted almost. And these are like doing some mechanical parts. It might be some sort of hydraulic works, transformations are there, kind of very old mechanical things are involved with these computers. These are actually not used nowadays. But the digital computers, you may see digital computers based on digital 1 zeros. These digital computers are applied to everywhere in the world. applied to everywhere in the world. Nowadays, these digital computers are the most powerful instrument in the world. It's with you forever. Without that, you might lose your life. You might lose your half of your life. You might can't live actually. That much of merge, that much of inject for us by this digital computer. These are revolutionary versions, but I'm just make sure to you that you have some understanding about these classifications are there. You don't want to much worry about this, but have some sort of small understanding about these historical situations also. Right. uh, Actually, I'll answer all the questions at the end of the sessions, right? But you can chat with me. You can keep the questions in your chat and I'll answer end of this presentation, right? Right. Data and information. Now, what is data and what is information? This is very interesting point. This is very important in the other way around. Data. What do you mean by data? Data is a collection of raw facts. Or raw facts means a figure or a symbol, number, words, images, videos, whatever. It's in the raw version. There's nothing processed, right? Uh, I'll give example for you. Give an example for you. You have a Gmail. You now you have created a Gmail, right? Everyone, probably more than one, sometimes 3 to 10 Gmails you may have, at least two. I'm pretty sure everyone using at least two Gmails for you. Somehow you have filled this form. What you have provided is you have provided some sort of data. These are not information actually. These are data. Your first name, your last name, and your username, password, and everything. So these are data. There's no information in here. I'll come to here. Manipulated data is known as information. Now, these are data. These are not information. Now, you may realize, no, there's some information. No, there's no any data. No any information, sorry. There's no information. There are set of names, there are set of ages and marriage status. So, I'll ask a question from you. I'll ask a question from you. Let me know who are married. Let me know who are married. Now, there's a question. Now, you do have a data set. You do have a data set. Once I fire a question for you, what your brain starts, it starts manipulating. What your brain does is it visits to this column and it moves down, figure out what are the yes cases. What are the yes cases? Initially, there was a data set. But what was happened here? I'll ask a question from you. What's the question? Who are married? Your brain starts manipulating. This manipulated data, yes, this person is married and this person also married. Then your brain finds the name. It manipulated again. Yes, married, and what's the name? Yes, married, what's the name? Now, you can realize now, data is just a raw fact. It's just set of numbers, it's just set of characters. But to give a meaning, but to get a meaning, we have to answer a question, or there's a question. The answer is the information. My question is yes, then answer is these two people, right? I'll ask another question. Who are married and name starts with S. Now the question is more precise. What they are asking is married people, then you will visit this place and your brain starts to process the name. Your brain starts to process. What's the question? Married and name starts with S. There are two names. Married, yes, there are two names who are married, and which name starts with S here? See, after the processing this data, you will get the information. Now you are very clear. There's difference between data and information. Now you may realize information is gained based on the question that I'm asking from you, or the data set can answer. Now, now the core reason is this data set do not contain any data about that. To convert to as an information, there should be data. If there's no data, you can't transfer to information. Clear? So there's a highly coupling between this data and information. You can answer by manipulating data and converting into information. In the other way around, if you want to convert it to information, there should be data. Without data, you can't convert it into information because there's nothing to convert. Clear? There's nothing to convert. So in that case, there's nothing to convert, so no information. There is data and you can manipulate as you like. Then you can convert into information. Now you are clear about this data and information. Clear? Right. Now the next point, the computer hardware. Now what we have started is what is a computer, right? Now I'm mainly focus on computer hardware related stuff today instead of softwares and other stuff, because next few days we can complete this software, operating system and other general topics. So today we'll go through the computer hardware, and this might be very theoretical, but you should know some information. Some information is not majority to apply for you, but having general understanding is mandatory to work with the computer. Okay. Now you are not a doctor, but you have some understanding about eyes, ears, nose, mouth and other stuff, right? You are not a doctor, you are not a physician, right? But you have some sort of knowledge to live. Clear? In the same way, you should have some sort of knowledge about this computer hardware also. Now, what's a computer hardware? Is any physical element of a computer. It's a physical, any physical element, right? You can touch it, you can sense it. Now mainly there are three: CPU, RAM and the peripherals. Now probably you haven't seen these two components, CPU and the RAM, but some people have experienced, some people have gone through this thing. But peripherals like IO devices, input output devices, definitely you have used, like cameras, external hard disks, SD cards. Yes, right? You have used these things. So these two are like inside the computer, inside your laptop, but peripherals are outside the computer. So you have majority of the cases, like nearly like everyone has used at least one pen drive, at least a pen drive you have used, right? So simply computer hardware is a physical device. It can be do some sort of work. There might be a lot of works. So this work can perform based on this physical instruments, right? There are three: CPU, RAM and IO devices. Now, now we'll go to the input processing output cycle. There's a data manipulating cycle. What I told is initially computer is an electronic device that can input data, output, and storage and process the data. Right. So this is a computer, right? This is a computer, and I just little bit earlier I told about data to information. Right. Data is processed into information. Clear? In the same way, little bit very earlier, just I told about hardware components. Right. Now what I'm going to do is a computer. This is a computer, right? Input, process, information, and storage is there. Data converts into information, right? Same context. I'm extending how to input the data. How to input the data using a physical device or a hardware component, and how it process, and how it store, and how it output, how it gives to the environment. This cycle is very important for anyone who are involved with the computer. You should know there's an input, there's an output, there's a process, there's a storage also. There's a storage also. Right. Now we'll go through the input devices. Now definitely you have used lot of input devices, like everyone, at least everyone, like computer, keyboards, mouse, microphones, touch screens, scanners, and barcode readers. Barcode readers, lot of input devices are there. Right? These are like very common, and everyone knows about this. Right? I don't want to tell about these kind of microphones are there, these kind of touch screens are there, these kind of scanners are there. There are a lot of scanners. Probably you know, right? There are a lot of scanners are there. But if you come into the current scenario or the current age, this era, a lot of sensors are involving actually, rather than these. Now, everyone at least above 50% has used about heard about actually. Sorry, heard about self-driving car. So there's a small clip on here. You may see how much of input devices are there, that sensors are there. Right? See, it extracts the data. Google Map provides the data, and see this person is not touch anything. There are a lot of sensors. See, vehicle is identifying what's happening in the real world, what's happening in the outside. It processes the data in real time, in the same time what it extracts. After 1 second, there's no point. In the same time, it extracts the data and it stores and processes the data. And it provides the output in the same time. See how much sensitive sensors are there. It identifies in the same thing in the same time. So these kind of input devices are running in current world, right? This is very interesting point. This person even no need to touch. See how much of the sensors are there. It overtakes the vehicles and it stops relevant places and identifies the correct path. How much of processing, how much of input data is running in there, right? In the other way around, how much of time, it's very nearly real time, nearly 99.99, like 959 are there, right? If you miss it in 3 seconds or 1 second even, you'll get an accident, right? You'll get an accident. So this kind of sensors are running in the world. Not only these sensors, heat sensors, CCTV, there are a lot of sensors are there, right? There are a lot of sensors, current CCTV cameras, human face detection, and lot of things are there. So now these are the situations in current world, right? These input devices are the input devices that you have to learn, rather than the very old scanners and very old things. So you can search it from internet and you can learn lot of input devices. Like I have scoped down to very limited input devices, but you can go through like large number of input devices, even earthquake detection, tsunami detection, lot of hurricanes, everything was detected earlier by these sensors. So sensors are like very powerful input devices for computers, right? So you can learn, you can go through bit more and understand a little bit further and further deeper input devices. Now, the cycle that I spoke to you, like input, process, and output, this is the process. Then now you do have some understanding about. There are input devices. There are input hardware components are there. Clear now. It's very clear now. There are input devices are there. Or it absorbs the external data, external environment data, and it pushes into the computer. Once it pushes into the computer or it flows to the computer, there should be a processing, right? The common case, majority of the common case, it's like CPU, central processing unit. You might see like your computer is Core i3, Core i5, Core i7. So what's the meaning of this? This is like business brand actually from Intel. I do can process this much of information, this much of data. I do can process this much of data. Okay, CPU is the brain of the computer, right? What the human brain does, it identifies, it process a lot of things, right? The same way, computers are based. If your CPU is not working, furthermore, your computer is like dumb object. There's no point. And it was housed with a tiny silicon chip. CPUs are switches, turn on and switch off, turn off, because it receives instructions from the computer programs. Now, time to time, system generates some sort of data. According to that, CPU can process that data. We'll discuss within next few slides how this process is doing. And typical consists of there are four major modules. You can go through all of four major modules, but I'll go through little bit lower, like simple things, right? CPU executes instructions associated with the machine language. So machine language is that byte code or a 1-0 code, which is not human understandable. Human understandable languages are the natural language, Sinhala, English, French, Japanese, like human understandable, natural languages. These natural languages are for human, not for computer. Computer understands the machine language, the byte code, 1-0 code. There are 0-0-1-0-0-1-1-0-0-1-0-0. This is the language that computer identifies. Right? So CPU can execute this machine language, these byte codes, 1-0s, a set of 1-0s. Think like a machine that can extract human voice, an English word, and it translate into a machine language. Then only it can process. Until that, computer can't do anything. If you process anything using a computer, that means there should be a 1-0 or a byte code or a machine language is there. Unless it won't execute. Clear? Now, CPU is composed with ALU and CU control unit. Now, ALU is arithmetic and logical unit. It handles arithmetical operations. What are the arithmetical operations? Are addition, subtraction, multiplication, division, like what you are doing in like math. I believe everyone has used some sort of math now, because you all have done your O levels. So definitely you do have some math calculations has done, right? Your brain stuck in some point. If it is a 25 numbers with another 25 numbers multiplication, you're stuck definitely. You'll get lot of time to process this. But arithmetical logic, arithmetic and logical unit can process this data within milliseconds. Within milliseconds, this much of speed is there. And logical operations. What are the logical operations? AND operation, O operation. Probably you have heard or learned in somewhere like Boolean logics. What the Boolean algebra does is, it's not the normal algebraic solutions. It process AND. Like I'll write small AND operator in here. If like 1 1 0 1, if you want to add these things, then think it's like this. Then there's an AND operator. What's AND operator? AND operator is if both sides are true, the answer is true. So the answer is based on that. You can't do the normal algebraic mathematical solutions for this. Instead of, you have to use Boolean algebra. So the Boolean algebraic related stuff is handled by this ALU, arithmetical and logical unit. Clear? Now ALU has mainly two things: arithmetic and logical operators. Logical operator, arithmetic operators are the operators that mathematical operators, and logical operators are the Boolean operators. The next one, like CU or the control unit. Now I told, right, CPU executes instructions of data. Right? CPU executes the instructions. Now without a sequence or an order, CPU can't process anything. There should be a proper line. Now if I'll get a simple example, if you are watching a movie in YouTube, right, think if you receive some sort of data after 2 seconds time to time, what would be a movie? Some characters are there, and after some seconds another character arise and it was loose, another character comes. Think it's like messed up. It's a messed up, right? So there should be a sequence. There should be a, which should arrive in a proper sequence order. This order, back to the computer, this processing sequence order is conducted by this control unit. Now you do have very good understanding about the sequence is very important. If the sequence is gone wrong, your operations will be some sort of different answers. You can't realize what the answer is, at least. Now that is main two components, ALU and CU. There are a whole lot go to more deeper, but I'm not going to much deeper, like, since it's like very beginning lecture, I don't want to make you into a trouble. So instead of, I'm getting very simple stuff, ALU and CU. Now CPU chips include with a cache memory, right? Now this CPU executes the instruction sets, right? I told, right, it executes the instruction sets. Now I told there are two components also. Apart from that, there's a cache. Cache is storing temporarily, but it's very fast. These chips, these small CPU chips contains set three layers of cache memory. The main job role or the main purpose of this cache memory is temporarily store the data and the instructions for fast access. We want very fast processing. There's a mechanism. Once CU defines the order, how to execute it, how much fast you have to execute, right? These kinds of things are doing by this cache memory. We'll discuss a little bit later this cache memory also. Now we have discussed about, like, there are major components are there, and there's input output cycle, input process output cycle is there. Now how this process is conducting? This process is known as fetch, decode, execute cycle. Fetch, decode, execute cycle. I'll go through this slide also. This is very simple concept actually. There's no any hardcore, very simple. The basic operation of CPU is fetch, decode and execute cycle. CPU fetches instructions one at a time. Now, though the computer is very fast, it fetches or it grabs, it takes instructions only, it takes only one instruction at a time. Only one instruction at a time. Instruction means it's a command. Go to this one, add this one. These are instructions. Right? What you are doing, 7 plus 5. There are 3 components involved. 7, addition mark, and 5. What you are doing, you are commanding computer, please add these 2 things and give me the answer as 12. Isn't it? Give me answer as 12. Your computer is process it. The computer CPU fetches the instructions one at a time. From the main memory that I told, there's a main memory, RAM. Simply you can get it into RAM. And from main memory into registers. Registers are the places that process very fast data. Very fast. Registers are very fast. Once register is the program counter, then fetches the instruction. It stores in the immediate access store. Now, what's happening here is it extracted data from the main memory to the registers. Are you facing any lagging actually? Does everyone is facing some sort of? All right. All right. We'll continue the lecture. And right. Now, what's the story behind this? CPU fetches the instructions. It extracts one instruction at a time from the main memory into the registers. Right? Then what it does is stored for access for immediate store. Now, think like you want to process a lot of data. If there's a difference in between the main memory to CPU, there's a time difference. You'll get if there's a 1 picosecond difference, your computer will get little bit slower. Even a picosecond is very valuable, right? That much of fast. So what they are doing is they store the data temporarily for immediate access. Now these are like registers. I told, right? These are referred to as registers. These registers are very fast. It stores immediately for immediate access only. It can't store for a long. Right. We have stopped with the registers. So what the registers does is it temporarily stored for immediate access. Then the CPU decodes the instructions. Now there are instructions arrived to the CPU. Then it decodes. Right. I'll explain this slide again. Now, what happens here, the fetch, decode, execute cycle here is like how the processor or the CPU execute the data, right, or the instructions. I told, right, there are a set of instructions are there. So these instructions, how these instructions are working. Now you may see this input, process, and output cycle, the same cycle that I'm continuously speaking. This is the control unit, this is the ALU, right? Now this is the immediate storage. Now you can see this image very simply without lot of words, and I'll go to this image. You may realize like this executes the process with the RAM storage, and there's a fetch also. It fetches and control unit decodes the data, right? Now what I was initially spoke is fetching cycle. It fetch from the main memory into the registers. So the registers are for immediate access storage, right? Immediate, very little time. And once it comes to decode, CPU determine what instructions to be performed. Now this is very valuable because under the decode process, under the decode cycle, under the decoding, it should realize what should be the process that I have to do, what should be the process that I have to execute, right? So that's the decode component. And execution executes a program that's stored as a sequence of machine language instructions in the main memory. Now you may realize, now it executes the process. Now it's decode and it's realize this is the order that I have to process. This is the order that I have to process. Now it processing the data. It executes the data. Executes a program that's stored as a sequence of machine language instructions. Now machine language are again 1 zeros, and it repeats until there's no instruction. So this is very simple process. As the first time, sometimes lot of students are getting stuck. So you can go through again and again and understand about a little bit furthermore. But in the common scenario, you might never touch these components, but you should have some understanding about this fetch, decode, and execute cycle, right? So there's a small home activity that I want to suggest you. Now we have discussed about components, right? Input, output, and the processing components. So there's a architecture called von Neumann architecture, right? There's a small PDF also. Please refer this PDF also, and I'll give a space for you. What you have to do is you have to write a small report. This is kind of self-learning activity. There's no special marks I'm allocating for this one, but it might valuable for your quiz. Hopefully, Samadhi sir told about that your marks, right? So in that case, what you have to do is you have to face few questions related to von Neumann architecture, right? So it's good to write your own words, good to understand, and upload it. I'll create a separate link for you. Don't spend too much of time. You might spend around 1 to 1.5 hours, not more than that. It's more than enough to get some sort of understanding about what is von Neumann architecture and how it works. This is one of architectural solution under this context, right? I'll keep it here for you. You can go through a lot of online documentations are there. As a self-study component, you can work on this. I'll create a separate link today evening, and you can upload your documentation for there, right? Make sure to read this additional reference also. Just double click this document, then it will be open, and the same way I have mentioned it in your reference or the additional resources section also. Right. Now we have gone through input, process, and the next one is storage. Now hope we are in the same line. There's input, there's process, right? This is input. We have discussed about the peripherals that involve with the input devices, and we have discussed about the processing, CPU and related stuff, right? Now the next point I want to discuss is storage. Storage is very important. This is the place where storage, right? Hope you can remember the diagram. This is the storage. Now I'm going to discuss about this storage component now. Now storage devices, it's a piece of hardware component used for store the data. You store the data for future reference, or it might be protect for future use, or you might need to have a backup for your data, because data is very valuable. If you lost some data, sometimes you can't regenerate the same data. Think you got some photos in 2015 with your friends, and your computer corrupted and all of your photos was lost. Unfortunately, no one stores that photos. Yourself, you are the only person who store that photos. You can't recreate it, right? You can't recreate the same data. You can't go back to 2015 and get the same data, get the same photo with the same friends, isn't it? That's the story. So storage devices are very valuable. So you should know basic components of storage devices, how to handle, how much valuable of these storage devices. Right. Now these are hardware components, and there's a separate component of softwares also. Only with the hardware we can't store anything. There should be a software component also. We'll discuss it in near future. But for today, we'll discuss about this storage devices in the perspective of hardware, right? USBs, flash drivers. Hopefully, no need to tell about these flash drivers. I believe everyone used these flash drivers. SD cards. I'm pretty sure everyone is using at least one SD card. And hard disk drivers, definitely, because your computers store the data in your hard disk drive. Probably you can see it's formatted for C drive and D drive. I'm speaking about your computer. You can go to your computer and see your hard disk is formatted to C drive, D drive, sometimes E, F, different hard drives. Right. Now, the next component is floppy disk. Actually, no need to learn about these floppy disks thoroughly, right? Just you should know there's a component called floppy disk. That's it, because it's almost dead, right? CDs, it's moving towards death, still not, but it's moving towards. DVDs are in current scenario, but I'm pretty sure within next few decades, DVDs will be die. It won't stay for next 100 years, right? Because it's evolving very rapidly, and there's no need to carry out the data from one place to another as a physical device. Instead of, there are a lot of mechanisms. I'll give an example. If you want to send a small document to your friend, if your friend is it's a neighbor, like the next house, what you are doing is you'll upload it to your Gmail, or you might WhatsApp it, right? You might WhatsApp it. You don't want to take it physically and move to there. If you go for a like small uh, photocopy centers, printout centers, what you are doing is you just upload your document into your WhatsApp and send them. Right. Now, what I was spoke is like hardware components and storage. These storage devices. What I spoke is like WhatsApp and Gmail. What you do is you don't physically carry the data from one place to another place. Instead of that, you will use another digital medium. Right? That's the current situation that we are working. We do not want to take one data from another data to move to another place. But there are situations like backups physically it transfers to some another locations. There are situations like that. Physically we have to transfer. But in common scenarios, like common cases, we use minimum storage devices. Even sometimes you haven't used a pen drive for last 6 months or last year. Probably what you have done is you have emailed your document, or you have uploaded to YouTube your movie or whatever small clips, or even you have shared through Facebook with your friends. That's the scenarios that we are currently working. But behind the scene there's another storage devices also. These are like advanced storage mechanisms, but it's okay. But general sense, you have to learn about these storage devices. And most importantly, if you are using a hardware device, especially like storage component, I would like to highly advise you use it very carefully, because if your data is lost, it's really hard to back up the data, get back. It's really hard to get the data back. Okay, so if you are using physical device to store your data, make sure to use it time to time. Check whether it's working properly, because there are all of these hardware devices are small semiconductors or silicon or germanium semiconductors. There are electronical situations that are not perfect. So my advice is keep a backup always. Keep a digital backups, cloud storage. Like you can store Flickr your photos, you can store Google Drive the valuable documents, or whatever the documents, whatever you have, and you can use YouTube to store your data, upload the videos, and make it as private so no one can access. Clear? So that's the context of these storage devices. And I'm discussing about little bit another interesting component. Now we have discussed about the hardware storage, and there's a memory. Right? Memory. Now this memory also kind of like very involving or evolving things. Like, so you can see there's a hierarchy from L0 to L5, and CPU registers holds from L1 cache registers. I just told you there's a register that temporarily holds the data. It temporarily holds the data. And there's a L1, L2 cache. Actually, there's a L3 cache also, but majority of the cases L1, L2 is sufficient enough. These are very fast, but you can't touch it, but you can't change it. Think now, if you want to speed up your machine, And if you think I want to change my L1 cache, there's no way to change your L1 cache or to your L2 cache. Those are like inbuilt components. If you want to change, you have to change a whole set of components. You have to change a set of components, right? And main memory, you have some understanding about this main memory now, and the local storage, the secondary storage, usually your disks, and remote secondary storage. These are like not connected to your computer directly. They are might distributed in somewhere else, but that can store the data to your from your computer, or it can retrieve from that hardware device to your computer, right? These are very fast, smaller, fast, very fast. These are very fast from this side, very fast, very fast. And the other way around, these are cheap, these are very cost, these are very cost, these are comparatively, these are low cost, these are very high cost, very high cost. These are comparatively low cost, right? And the other way around, CPU directly involves with this registers, and L1, L2, and L3 caches also retrieve the data from main memory. There are 3 levels actually. There's another level in between this also, L3. These levels are involving in the main memory also. I'm really sorry, the last questions also gone, so I'll answer the all questions at last, but I'm really sorry, because of that internet loss, every question was gone. So please make sure to ask the questions at the end, right? But you may raise your questions in that time. I'll answer at the end, right? And this main memory, and inside the main memory, it's like processing, like storage. It retrieves from the local disks, and secondary devices. It's like very common. It's not much. It's very low cost. It's not very fast enough also, but now you will realize it's really fast, right? You will watch a movie very fast without any issue, right? There's no transfer speed, transfer difference you can see. But I'm speaking about the general context comparatively to these registers are too fast. According to that, comparatively these are not fast. Clear? Comparatively these are not fast, but these are really fast if you compare with the human, right? If you compare with the human, these are very fast than human. Now this is like small memory hierarchy. You have to learn about these things also, like very simple components. You'll learn much deeper. There are very, very deeper concepts also there. You can go through as a self-study and improve your knowledge furthermore. Right. Now, what we are speaking about, this memory components are volatile and non-volatile. What's the difference between volatile and non-volatile means, if the computer power is not there or power is lost, this volatile memory would lose all the data. These are the volatile memory. These are the volatile memory, right? All these components lose their memory once you shut down your computer. That means it's not store any sort of data furthermore after your power is gone. If you switch off your computer, that's it, everything will be loose. But if you sleep the computer, caches are usually working. It won't totally gone, right? In the other way around, non-volatile memory, These are the disk storage, your C drive, D drive. There are another set of non-volatile memories. These would never lose the stored data. It won't lose the stored data due to any electronic interconnection. Clear? So that's volatile and non-volatile memory. So what's the most important point here is, if you store some sort of data for a future use, for long-term use, you have to use non-volatile memory. But these are comparatively slow. These are very fast comparatively this, but these components do not store data for a long time. Usually it just extract the data and supports for processing, and it ignores everything. Now you are clear about what is volatile and non-volatile memory components, right? Now we are in a good position, like we have discussed about input, process and storage, and we have to discuss about these output devices, right? Now the data is input from the environment to this place, and it was processed, the data. If you want, you can store the data, and sometimes there might be stored data can be processed here, and extract to the, or provide data to the outside as an information. How it performs is by using an output device. Now we'll learn about output devices. These are hardware components, and this hardware device that can present information to the human. Now ultimate goal of the computer or use of computer is there should be some sort of output, right? There should be processor and everything is there, but there's no any output. Everything was done very successfully. It's processed, stored, everything was done. You input some sort of data. I'll give example, like your face is detected by the computer input device. Your camera performed well. It detected your face, and everything was worked fine. It's processed and everything, but there's no any output. I think it's a face recognition based. Your computer is switch on, or login is performed based on your fingerprint. Input is perfectly done, process also perfectly done, but there's no any output. There's no point, right? There should be an output device to work, to get the fruitful output for us from the computer. Unless there's no point, right? This output mechanisms can be visual, sound, format, any printable format, or any other terms, some sort of sense. There are 5 senses for us. Some sense should identify the output. If not, there are some sort of output devices that provide an input to another device. There might be situations like that, right? There might be situations like that also. But in the common scenario, the common way that we are speaking about, output devices are the devices that can grab the information or present the information to another human. Now these are very simple things like monitors, printers. There are a whole set of printers probably you have learned in your school time. There are a lot of dot matrix, lot of printers. I'm not speaking about these printers. Speakers, there are whole set of speakers are there with the size, amplifiers, different kind of things, and headsets. Now we are in a generation like BRs, ARs, kind of things, right? Hopefully at least 10% of you have used at least a small VR headset or something. At least few students have used. Very, very interesting. So I do have a small video clip about this output device. Now, see, this is an output device. See, it's happening here, right? It's virtual view. Right. Now, these are the output devices that I want to see from you, right? These are Google Glasses, and there are Apple Glasses also. There are products, different manufacturers are there. VR headsets, lot, right? You can learn about these output devices. I'm not moving towards deep on these output devices, but these are very interesting output devices. Instead of that standard printers, monitors, speakers, and stuff, like these are like, even like grade 7 students are familiar with these, but I want to see from you some deeper output devices. Now, while you are walking, while you are searching, while you are visiting, while you are doing some work, if you visit the special kind of place, you can see like very attractive output devices are there, right? So search about these things. You can find through internet what are the latest output devices. There are a lot of output devices, right? Lot of output devices are there, so you can go through these things and understand well more deeper and deeper about these output devices. And if you like to enjoy with this, you can have some, and you can enjoy with these output devices also, right? Another topic that I want to speak today is computer generations. Now, there are five main generations in computer world: first generation, second generation, third generation, fourth, and fifth, right? Again, I'm not going to discuss about these ancient stories, and I'm not much spending time with you for these discuss with these very ancient stories, but you should know the basics, right? Very basic components. What can I do is I'll assign another self-study assessment for you. You can go through documents, you can watch videos, different kinds of materials are there. You can learn about these historical stories. There are a lot of historical stories, and even I have seen the years are differ in different documents, so it's okay. Actually, I'm not much focus your subject on these computer generations, but you should know the basics, but the historical, how these historical evaluations, or sorry, historical uh, changes are done, different versions arrived to the world, why they was arrived, what are the major issues that they faced at that time, how they solved, and why it was a huge jump in between one step to another step. So you can do a small case study, you can learn your own, and I'll upload another link You may spend around 1.5 to 2 hours, not more than that. It's more than enough to spend around 1 to 1.5 to two maximum. Don't spend more than 2 hours, right? Do a small study on this and create a small document and upload. I'll create another link for you in Moodle so you can upload. This also not for marks, but for you, right? Not for marks, but for you. But there might be few questions in computer generations in your uh, assessment quiz. So it's good to ready for that also, right? Now we have learned about whole set of scenario. What's a computer? The same context we have evaluated input, processing, storage, and output cycle, right? And what we have done is we have understood about storage, sorry, input devices, different hardware devices. And once the data generated from input devices, it processes by CPU. There are components, ALU, CU, and there's a fetch, execution, decode cycle. These are we have discussed. And further, we have discussed about the storage mechanisms, how the storage is done, volatile memory, non-volatile memory, hierarchy, those kinds of stories we have discussed. And further, we have discussed about output devices very simply, right? We have discussed about these output devices. Finally, we have discussed about a small, actually it's for you for the computer generations. Now, these are some sort of additional resources that you can do. Definitely what you have to do is you have to go through these 3 documents. It's mandatory, right? Because what I'm doing is for the quiz, I'll add around 5 to 10, not more than 5 to 10, 5 to 10 questions from these additional resources. So you can go through, and I'm not let you to go very deep like a computer science student to understand about these concepts. Probably these are like not much interested for you. I can realize it, but the computer science students do very deeper understandings. But you should know the basic components. And in the first research paper, there's a small, actually it's a technical paper. There's a hardware architecture and another story that they are speaking about. How this story is going on, and there's Britannica. I'd like to recommend you to go through. This starts from the computer, and there are deep discussions like supercomputers, mini computers, and different stories they are speaking. So you can learn about that. There's another small video clip. If anyone is facing like data issue, what can I do is I'll download it for you and I'll upload it to Moodle. Then you can download it. I'm sure that there's no data cost for your Moodle. If you need, please let me know. If not, you can watch it from YouTube, right? These are kind of nice stories. Sometimes it might some dull discussions for you, but you should know the basics actually, right? That's all today that I want to share with you. I'll go through another small hands-on work, right? Uh, Now, what I'm going to do is I'm going to show you some there's a question like There we can find the links. I have uploaded the PowerPoint presentation to Moodle. You can download it. It's in the last, not the last one before the last or something like slides. Right now, I'll go to control panel. Now what I have done is I have just pressed my Windows button, or you can click the start here, then you can type control panel. Please make sure to go with me, or make sure to learn this, because I'll upload another place to work on this also, because this is very important for you. Now I'll go to system and security. I'll go to system, right? Control panel, system and security. I'll go to system. Now once I go to the system, what can I see is I can see the processor. What's my processor? It's i7. That this time I'm spending to you for like your general knowledge. You should know the basics of computer, and you should have some sort of like not only the theoretical work, but you should know the basics, how to express. Like if your friend asks about Machan, what's your computer, i7 or i3, then if you think like I don't know, there's no point of your degree, right? There's no point. So it's mandatory to learn about these components also. Now if someone asks about what's your processor, what you can do is you can go to this settings, and you can see this is the processor i7. Please go to your computer and check whether your computer is i7, i3, i5, or it might be Atom or whatever. Something is there. I believe that right. I believe everyone visited to this place and found the processor. What's the processor that you have? And this is the RAM that I have spoke, right? 8 GB RAM. I do have 8 GB RAM, but the story that they are speaking is 7.81 is the usable. There is a space that is unusable, that's using by the computer. Clear? Yes, you want to show the path. I have gone to here, start. Then I have type control panel. Control panel. I have clicked this. Then I have gone to the system and security. Then I have visited the system. Right now, this is my RAM. This is 8 GB. Now, see if your friend asks about what's your RAM, Machan, what's your RAM? Hey, what's your RAM? You should know what's your RAM. It's 8 GB RAM, at least, right? At least you should know what's your RAM and what's your processor. It might be i3, i7, whatever. These two, like without, if you don't know these two, at least there's no point. This is the basics of the computer. The last what, like 2 hours, nearly 2 hours, I have discussed about kindly like theoretical and untouchable or things. This is like touchable, practical situation. This is the processor, this is the RAM. If your computer is too slow, you can increase your RAM. Actually, this is very easy. There's a small socket. You can, this is plug and play like a game. It's very easy. If it is 8 GB, you can upgrade it to 16 GB. But there are limitations. If you have 4 GB, you can't upgrade to 16 GB. But 8 GB can upgrade to 16 GB, right? You can't change this i7 to i9 or some another thing, right? You can't change it because this is right? I'll come to this system type. There's a question, what is this system type? There are 32-bit and 64-bit. There's a operating system discussion, like it's fifth week around I'm speaking about this. There are two kinds of operating systems, 64-bit and 32-bit. We'll discuss about that component in that lesson. For now, you should know your processor and the RAM, as well as you can see the version. I believe that everyone is using Windows. If not, please let me know if you are using Ubuntu or Mac. Then you have to go through your path and find what are these things, right? At least you should know what's your processor, what's your RAM, and what's your OS version or the edition, right? These three things are mandatory. So what I'm asking you to do is you can take a screenshot of this place and upload into Moodle. I'll create another link and I'll give around 1 mark or 1%, whatever, some amount I'll allocate for this work. If you want to move to the same location, there's another way. I'm going. All right, I'll discuss about the generation later, right? There are computer, like this computer generation is not, there's a message. This computer generation is not actually the generation that we spoke. Like we have spoke about 1, 2, 3, 4, 5, fifth version, fifth generation kind of thing. Right? Generation is your first generation, 8th generation, 9th generation kind of thing. I'll discuss about that is in the future also. But for today, I'll go to the same thing. I'll go to my computer, my this PC. Then I'll right click and I'll go to the properties. Right? In the same way, then you can see the processor is i7 and RAM is 8 GB. Right? Have you seen? There are two. I have discussed about two ways. First one is go to the control panel, and find your details, system security. Then go to the system. Then you will find these details. Or you can go to your computer and properties. Same information will visible in here. Clear? Right. One more last thing that I want to show you. I'll go to the control panel again. I'll go to the system and security. I go to the system. Now you can see the display. I'm here. My display related information would presents in here, right? Your display resolution, orientation. Please go through these things and get some hands-on experience. And sound. You can see my sound speakers and input, right? My voice is here. Can you see? Like different kind of things are there, and just you have to go through and identify what are your input and output devices in your computer, right? That's it. If you have any questions, please ask. I'll create 3 places for you. First one for von Neumann, second one for generation, third one to check your computer, RAM, and your processor, right? These are mandatory. Third one is very mandatory. This is mandatory, right? I'll share separate locations. Third one, I'll think about to give marks or not. Any questions now? I'll give around 1 to 2 minutes.
So I have a question.
Yes.
So in Microsoft Office, I have 2010. Is it
Okay.
okay? It is okay, or I should want to download latest version?
If you have the latest version, that means it's really nice, right? But if you are facing any kind of issue, 2010 is okay, but good to install a newer version actually. Then you can run with me now.
Okay, sir.
You got the point, right? No need to explain again. Yes. Yes. What are the questions? Path, system type, generation. Yes, what you have to get is only the screenshot. Actually, it's for yourself. These are for self-learning, because uh, what I was realizing is some students, at least like third years, do not have understanding about your processor and RAM. So it's mandatory to learn in first year. That's why I have given this work for you. Right? There's another question. Yes, take the screenshot and upload it. Yes, computer generations work that you have to do is just go through the 5 generations in computer. Then what you have to do is write a small document. Like, I don't want to make it very fancy or copy paste from somewhere else and add lot of images and like very drastic story. Just like 1 page is more than enough. That also for your understanding. Even if you haven't uploaded, I don't care about that. It's okay at all. But it's good to learn about for you. That's why I'm telling, like, you can learn around 1.5 to 2 hours about computer generations and write small story, a discussion about these 5 generations. That's for you. I'll upload the links to all the homework. Then you can work on those homework and upload these documents. Yes, Moodle, as per my knowledge, it's totally free, but I'm not sure 100%. I believe it's free. Yes, you can write and upload. It's okay. If you don't know how to work with Word, it's okay. You can use your pen and paper and write it and take a photo and upload it. It's okay. I'm totally okay with that. Actually, there's a question that you have to complete it today. Not at all. I'm not like stress you to complete it today, but you can learn for you. I'll upload it like around 2 to 3 weeks. Then you can upload it. I'm flexible at that point, right? There's a question how to upload the third one. What you have to do is you have to upload, uh, get a screenshot. Hopefully everyone knows about how to get a screenshot. There's a button in your keyboard called print screen. Then you can print the screen, then open paint and paste it, control V, paste the document. You can use the shortcut control V. Then you can file save as a PNG or something. Then you can upload it very easily, or you can paste into Word document and upload it. It's okay. There's no deadline for homework. There's a question, is there a deadline for homework? No deadline. You can take your time. It's okay. There's a question actually. I can't connect my laptop with internet, so I join Zoom my mobile. Is that okay? No, it's not okay for the next day evening session. Morning session, okay, I told about that, but for evening session, I'm doing practicals. So you have to ready. Actually, I'm not forcing you to use your computer, but you can keep your mobile phone side and you can do with me. It's okay. If you have some sort of issues with the internet stuff, it's okay. You can use your mobile phone and keep it like nearby you and work on with me, right? Sir, can you tell what are the 3 homeworks? Yes, I'll upload the links. Then you can go through these homework. Yes, there are a lot of questions. What are the homeworks? Yes, no. I'll upload the links there. Then you can view that work. What you have to do, right? No special fonts. There's a question like any special fonts. No special fonts. You can use Times New Roman or anything. It's okay. Yes, you can use snipping tool and get the screenshot. There's a question, can we use snipping tool? Yes, you can use snip and you can save it. Mac machine, yes, Ravindu, probably Mac also there's some sort of processing and RAM is there. So please check it and you can get that one also, right? You have to search in internet. Oh, there's no any laptop. So what we can do then, at least you don't have a desktop. You should have a laptop or a desktop actually, unless it might be a problem because next day onwards we are doing practicals. So highly ready for that. Sorry, I can't help you at that point. Yes. If your computer is not working at the moment, it's okay. You can upload at anytime. It's okay. Yes. Any more questions? Hope I have answered all the questions. Any more questions? Uh, Next week, there's a question next year or next week, right? Work, next week we are doing Word. Yes, I don't care about the device that you are using for your practicals. You can use whatever the device that familiar with you. It's okay. Yes, I told like I'm sorry about that laptop issue. So you can do something else, or you can do it later on. It's okay, right? Can I can realize that if you don't have a laptop, it's okay, right? What to do? Uh, if you don't have a laptop, you can stay a little bit time and you can work later on. It's okay. Uh, Sorry, I don't know about the laptop loan situation. I'm really sorry. Right. Right. Now we have done the lesson. So thank you everyone joining with me and especially bearing with me with this internet related issues also. So I hope that you have learned something valuable. And if you want to share with me anything, you can mail me. My mail address is in the PowerPoint presentation. You can mail me, or Samadhi will. You can talk to Samadhi. Then Samadhi also help you. There's another instructor. She also can support actually for anything. So thank you everyone. We'll meet next week morning again. Right.